So for the last section of 5.12, we're going to talk about applications of quadratic equations. So we're learning how to solve applications involving these quadratic equations. So let's review the 5 steps for solving applied problems. So the procedure. First step, we want to read. So we want to read the problem carefully, more than once if necessary, until you understand it. Draw a picture. Identify what you're being asked to find. Step 2, we want to choose a variable. So we want to choose that variable to represent an unknown quantity. If there are any other unknowns, define them in terms of the variable. Then we want to translate. So translate the problem from English into an equation using the chosen variable. In step 4, we want to solve the equation. In step 5, we're going to check the answer in the original problem and interpret the solution as it relates to the problem. Be sure your answer makes sense in context of the problem. Alright, so we're going to look at solve problems involving geometry. So with this one, our first example here, a rectangular vegetable garden is 4 feet longer than it is wide. What are the dimensions if it covers 60 square feet? Well, let's look at this. Let's read it and draw the picture. So let's draw a little rectangle. So this is a rectangle. So we draw a rectangle, alright? We got this set up right here, a rectangular vegetable garden. And we see that it is 4 feet longer than it is wide. So W can be our width, and 4 feet longer than our width gives us our length overall. So now we choose a variable represented the unknown, which we did was W for width, and our length was W plus 4. So now we can translate the information that appears in English into algebraic equation. So we're given the area of a rectangle in the garden, which is length times width. And we use this formula to get the area of the rectangle and substitute the expressions above for the width and length and 60 for the area. So we have A equals 60, we already know. And now we know W times W plus 4. Right? So we're going to substitute in that 60 for the area, width is W, and length is W plus 4. We're going to do that just like that. 60 equals W plus 4 times W. So let's solve the equation. So we got 60 equals W plus 4 times W. Distribute that W into the parentheses. So where we get 60 equals W squared plus 4W. So then we need to write the equation in standard form. Which remember, that's A squared plus B, or AX squared plus BX plus C. Alright, so let's do that. So we got our 0 equals A W squared plus B, which is 4W, minus C, which is 60. So we've got it set up in there. Remember, that standard form is 0 equals AX squared plus BX. Goodness, my plus sign is not working. There we go. Plus C. Okay? So now that we have it in our standard form, let's go ahead and factor it out. Now with this one, because we have our A value is a 1, we can do the big X like I showed you how to do, right? And so up top is A times C. So our A value is 1. Let's go ahead and write these out here. A is 1. Our B value is 4. And our C value is negative 60. So A times C gives me negative 60. And our B value is 4. So A and C multiplied together, these two numbers over here need to multiply together to give us negative 60, but add together to give us a positive 4. Well, two numbers I can think of real easily is saying a 6 times 10 will give me 60 for sure. And if we need a positive 4, let's make that 10 a positive value and make our 6 a negative. So negative 6 times 10 gives me negative 60, and negative 6 plus 10 gives me a positive 4. And if you do that, then if you did bottoms up and wrote W minus 6 times W plus 10, we should get our factor, which in case they did, they got W plus 10 times W minus 6. So the same values we got. So now we can set each factor to 0. So we set the first one, w plus 10 equals 0, and then w minus 6 equals 0. And when you do that, all we need to do on this first one is subtract 10 from both sides to solve. So we get w equals negative 10, and then we get w equals positive 6. So now we need to check the answer to interpret the solution and if it relates to the problem. Since w represents the width of a rectangle, it cannot be a negative number. So w equals negative 10 is not a solution, right? We can't have a negative width, otherwise you wouldn't even have a box. Okay? So therefore, the width is 6 feet, which makes the length 6 plus 4 equals 10. Alright? So with that, remember, our equation was w plus 4 for the length. So our w being 6, 6 plus 4 gives us 10. So our width was 6 feet and our length is 10 feet. That is the final answer to check off. You wrote that out by using context as far as it's using feet and which one is width and which one is length. Alright, our second example here. Let's find 3 consecutive even integers such that the sum of the smaller two is 1/4 the product of the second and third integers. So again, let's read the problem carefully and identify what we are being asked to find. We must find 3 consecutive even integers. So then we need to choose a variable to represent the unknown and define the other unknowns in terms of one variable. In the terms of the variable. So let's say x is our first even integer. Then we say x plus 2 is our second even integer, and x plus 4 is our third even integer. So now we need to translate the information that appears in English into an algebraic equation. So let's read the problem carefully, breaking it into small parts. So we need the sum of smaller two integers, right? So we need the sum of the smaller two is 1/4 the product of the second and third. So for our equation, we can simply write this out. The sum of the smaller two we had here was x and x plus 2, add those together, and equals for is, and then 1/4 the product of the second and third integers. So then we got the product of our second and our third integers. So we should get x plus 2 times x plus 4. And then all that times 1/4, right? So this is 1/4. So now let's see what we got on the next slide. So now we can solve this, right? We've got that equation. And now we just need to multiply with some brackets and gather like terms. So in this case, you see we got x plus x. Those parentheses are pointless because there's nothing else you can do inside of them. So you got 2x plus 2. And that equals 1/4. And then we multiply by the FOIL method here. We said x times x is x squared. X times positive 4 is 4x. Then we did 2 times x is 2x. And 2 times 4 is 8. Then we should combine like terms, in which case we took our 4x plus 2x and gives us 6x. And those are the only like terms we can combine right there. So now we need to multiply both sides of the equation by 4 to get rid of this fraction. Because again, what they're saying is to multiply this side by 4 and multiply everything over here by 4 as well. So therefore, these 4's will go away and we'll be left without a fraction over there, multiplying by that group of x squared plus 6x plus 8. Okay, so that's all they did there, is they wrote out exactly what I just wrote out. In which case, as you can see, these 4's will go away and we'll simplify. So we took 4 times 2x gives 8x, 4 times 2 is going to be 8, and then we're left with just x squared plus 6x plus 8. So now we need to write standard form. So we need to make 0 equals ax squared plus bx plus c. So with that, we're going to say we subtract 8x from both sides, and then we're going to subtract 8 from both sides. So the 8x goes away, and our 8 goes away over here, left with 0. X squared doesn't happen. 6x minus 8x would be negative 2x. And 8 minus 8 gives us 0. So therefore, we're left with x squared minus 2x equals 0. So now we need to factor that out. So we set each factor equal to 0. Again, we just need to factor out an x to make this a little bit easier. So x times x is going to be x squared. X times the negative 2 is going to be 2, negative 2x. So now we can set each one of these equal to 0. And solve for this, right? So we take x equals 0 and x equals 2. Because the same thing as saying x minus 2 equals 0. So if you add 2 to both sides, it goes away and you're left with x equals 2. And there's nothing to mess with over here. X just will equal 0. So we get two solutions. If x is 0, then the other even integers are 2 and 4. If x equals 2, the other even integers are 4 and 6. So the answers are 0, 2, 4, or 2, 4, 6. It could be either one of those sets. Alright, so now we're going to solve problems using the Pythagorean theorem. So recall the right triangle contains a 90-degree angle. We can label it this way. So you got your hypotenuse is your C, okay, and you have your legs of A and B, right, and you have your 90 degrees right there. So the opposite side of the 90-degree angle is the longest side, which is called the hypotenuse. The other two sides are called legs. The Pythagorean theorem states a relationship between the lengths of the sides of a right triangle. This is a very important relationship in mathematics and is used in many different ways. So, Pythagorean theorem, given a right triangle with legs of length A and B and a hypotenuse of length C, Pythagorean theorem states that a squared plus b squared equals c squared. Or you say the leg squared plus the other leg squared equals hypotenuse squared. So, this theorem is only true for right angles, or right triangles. So find length of the missing side. So we have a 3 for one leg, and our hypotenuse is a 5. So for our solution, since the right triangle, we can use the Pythagorean theorem to find the missing side. Let B represent the missing side and label the triangle. So we're going to label the missing side B. And the length of the hypotenuse is 5. So C is 5 and the legs are B and 3. So if we have a squared plus b squared equals c squared, let's substitute in those values. We know that a squared is 3 squared, b squared, and we know our c is 5, so we got 5 squared. So now we need to write the equation in standard form. Well, 3 squared is 9 plus b squared equals 5 squared is 25. And then if we subtract 25 from both sides, so that's all we did here, we subtract 25 from both sides, in which case that gave us 0 over here on the right, and we're left with 9 minus 25, which gives us negative 16. So b squared minus 16 equals 0. Then we just need to factor this guy out. So again, we have an interesting setup here. If you look at this, you have your a value is a 1, your b value is 0, and your c value is negative 16. So if you do your big X, okay, do our big X, a times c is negative 16, and our b value is 0. So we need to have two numbers. Oh, there's a 6 up there. I need to write 16. Two numbers that multiply together to give us 16, but add up to give us 0. Well, we know 4 times 4 is the same number that gives us 16 when you multiply them together. And if we make one of those negative, that'll give us a negative 16. And we add those together, negative 4 plus 4 gives us 0. So that should be pretty easy to see in that case. You do bottoms up, we should get b minus 4 times b plus 4. That's exactly what they got when writing this out. So now we can set each factor equal to 0. So we're going to take b minus 4 equals 0 and b plus 4 equals 0. And if you write it out, it's exactly what the numbers are in the parentheses themselves. We should get b equals 4 and b equals negative 4. Well, we solve for those. Okay? In which case, we circled the actual positive 4. And why is that? Well, because if you have a negative 4, it doesn't make sense in the answer because the length cannot be negative. You can't have anything less than 0 for a length. Okay? So now let's do another example here. So we have an object is launched from a platform with an initial velocity of 32 feet per second. The height h in feet of the object and t in seconds after its release is given by the quadratic equation. So you have h equals negative 16t squared plus 32t plus 20. So we want to find out these three things. What is the initial height of the ball? How long does it take the ball to reach the height of 32 feet? And how long does it take the ball to hit the ground? Well, let's look at this. So, since t represents the number of seconds that the ball is thrown, t equals 0 at the time of release. Alright? So, therefore, we can find our height. Since we're saying time is 0, nothing's happened yet, we're at 0, we can determine our height. So, if you put in t equals 0 and solve for h, you simply say h equals negative 16 times 0 squared plus 32 times 0 plus 20. And that simply, you can see, hopefully y'all see, anything times 0 is 0. So you get h equals 0 plus 0 plus 20. So our h equals 20. So the overall initial height of the ball is simply 20 feet. So our a value is, our a part I should say, is solved for. Initial height was 20 feet. So for part B, we must find the time it takes for the ball to reach a height of 32 feet when find t when h equals 32. Sorry, I got tongue-tied there. So our height is 32, and we need to find the time. So we substitute 32 in for h, and we're taking our base equation of negative 16 squared plus 32t plus 20, and then now we need to subtract 32 from both sides, and that's how we got a negative 12 right here. So we got negative 16t squared plus 32t minus 12, and with that, then what we did is we can see that all these numbers here are divisible by 4, in this case a negative 4, to get rid of that negative on the t squared. So we divided everything by a negative 4. So negative 16 divided by negative 4 is 4. Positive 32 divided by negative 4 is a negative 8. And negative 12 divided by negative 4 is positive 3. And 0 divided by negative 4 is still 0. So that's how we got this set up right there. And then we just needed to factor that guy out. In this case, took a little bit of math and playing around with the numbers. We knew we needed a 1 and a 3 to get our c value over there of 3. And then in this case, for our 4t squared, pretty easy to see, we should just take 2t and a 2t, because 2 times 2 is 4, and t times t is t squared. And then just worked out, in this case, the setup, after messing around with it a little bit here, we found out that it should be negative 1 and negative 3. So now we're able to go ahead and set those two factors to 0. So you have 2t minus 1 equals 0, and you solve for t. You came up with t equals 1/2. Or over here on this side, we have 2t minus 3 equals 0, in which case we came up with with t equaling 3/2. So how can two answers be possible? Well, after 1/2 of a second, the ball is 32 feet above the ground on its way up. And after 3/2 seconds, the ball is 32 feet above the ground on its way down. Alright, so that's a little bit how you got to think about it. Right? You're throwing it up. Initially, it hits 32 feet in a half second. And at 1.5 seconds, it's back down at 32 feet as it's already peaked and coming back down. So the ball actually reaches that height of 32 feet at those two time frames. So with that, let's look at the next part. So C is when the ball hits the ground. How high off the ground is it? It is 0 feet high. So find T when H equals 0. So we're simply taking the same problem we had of H equals -16t squared plus 32t plus 20 and putting in a 0 for H. And then as the same thing we did previously, all those numbers we should be able to divide by 4. Because we have -16, a positive 32, and a 20. All those are divisible by 4. Now let's get rid of that negative on our t squared as well. So divide by -4. In which case, then we're left with a very similar style problem. We need to factor. So we have 4t squared minus 8t minus 5. And factoring that out, we get 2t plus 1 times 2t minus 5. We set both those factors equal to 0. And as you see, it breaks down where we get t equals -1/2 and t equals 5/2. So, since t represents time, t cannot equal a -1/2. You can't go back in time and have a negative half second, right? So therefore, we're looking at t equals 5/2. So the ball will hit the ground after 5.5 seconds, or 2.5 seconds. So this is 5/2, which is 2.5 seconds. Alright, so that takes care of, we're dealing with our solving applications of the quadratic equation. Hope you learned a little something. I'll see you next time.